All right, NET 110, Week 1, Lecture 2. As I said in the last lecture, lots of slides from Cengage. So let's try to bang them out as quickly as possible. So we're going to start with Module 1, obviously, networking basics. Now this is Chapter 2. That's okay. This deck from Test Out, rather, not Cengage, corresponds to chapter 1 and a little bit of chapter 2 in your textbook. So, all right. So, some terms that you're going to need to know: IP, Internet Protocol. One thing, if you've been in IT for longer than 5 minutes, you know that we're big on acronyms. Internet Protocol Address. We'll talk about subnets. I might define the term for you in a little bit, but we're not going to actually do any binary math for a little bit here. Local area network. Metropolitan area network is a term I've never used in my life, except when I'm teaching a class that says, hey, talk about MANs. It's you're either local or you're remote, right? You're either local or you're wide area. I've never heard one of my networking peers, no matter what level career path he or she is in, refer to a man. Okay, it's software-defined networking. We're going to talk a little bit about that, and some encapsulation. Right, we might talk about OSPF, ISIS, and then multi-point generic routing encapsulation. And for those of you who haven't heard of it, right, there's this new thing here called the internet that we might touch on a little bit. We won't spend too much time on the internet, though. I don't know that it's ever going to take off and be a big thing. So excuse me while I take a cough drop here. All right. Intranet. You have a website for employee forums, things that I need to be connected to your LAN to get to. That's an intranet. It's web sites that are only available to people inside. And Arnold Schwarzenegger, of course, as the Terminator. Now, Terminators, geez, do we even use Terminators anymore? Bus networks, we had to use Terminators. I guess some folks might call cable ends Terminators, right? So the RJ45 end that you connect to the end of an Ethernet cable. And some topology stuff we're going to talk about. Yeah, what's this extranet you're talking about here? Again, this is a term that I highly doubt CompTIA is going to ask you on their test. I am certainly not going to ask you for a definition, right? It's anything on the web outside of your internal company. Now, technically, the dictionary definition's a little bit different, but okay, let's go with that. What I want you to know right now, an IP address is a logical address, as opposed to a MAC address, a media access control address, which is physical. Now, I'm going to skip over some of these, maybe not give them the time and tender loving care that they deserve, but only because we're going to be spending time working within them. Subnets are ways of taking IP blocks that would normally be larger into smaller chunks. That's the dictionary definition. Hopefully things will become much more clear for you later when we do some subnetting exercises. And what's a computer network? It's two computers or two nodes or hosts connected together to share information, right? That's the most basic definition of a local area network or computer network that there is out there. Okay? Wide area networks, generally, the thing that separates them from LANs or local area networks, geography. There's also some routing and different protocols involved in WAN connectivity. But again, we're going to touch on that. Software-defined networking, let's skip that for the time being. And internet versus intranet. You can read those on your own if you like. Okay. Here's the definition for extranet. Unless this shows up in other slides, this is the last time you'll hear that term from me. Okay, and topology, we have physical topologies and we have logical topologies. We're going to talk about both. It's not so important to me that you know the dictionary definition differences between the two, but on the actual certification exam, they might ask you to design a logical topology. And then in one of the performance scenarios, they want you to connect the physical topology. So you might be designing a star network, right, with a switch and maybe a router and a couple of workstations. Then they're going to want you to lay out the logical design. What are the addresses you're assigning? Okay, what protocols are you using and things like that. Okay, terminators. Bus topologies. I worked on a bus topology in the last bus topology I worked on was 2000, 2001. If you get a job at a company that's still using a bus network, run. Now, we have to talk about it because it's still part of the actual certification exam. I would be highly surprised if CompTIA said, hey, by the way, right, 10 base 2, with coax cable, thin net and thick net. Those might be terms that show up a little bit later. So what goes into a network? Well, nodes. Now, I use the term node or host interchangeably. Normally, I'll say host. A host is anything you can assign an IP address to. Now, there are other protocols out there, but we're not going to touch on those at all unless they show up in the slides, which means that they're part of the CompTIA curriculum. If I can assign an IP address to something, it's a node or a host. I don't care if it's wired or wireless. I don't care if it's a laptop, a PC, a printer, a server, a switch, a router. Okay? And if you don't know what those terms are, we'll touch on those as we move throughout the course here. We're going to spend lots of time talking about the concepts of shielded and unshielded twisted pair. UTP versus STP, Stone Temple Pilots, right? That's how you're going to remember that acronym. Shielded twisted pair or unshielded twisted pair. Fiber optic cabling. Coax cable looks strikingly similar to this. Okay? I don't know how much time we'll spend talking about coax, but fiber optic cabling has sometimes has dozens of strands coming out, not just one. Okay? And then, of course, Wi-Fi, which, believe it or not, requires cables. Why, yes, it does. Okay. On the back of your computer, in the wall where your computer plugs in, okay, this is an RJ45 jack. It is an 8-pin connector. And if you're old enough to remember landline telephones, that plug looks similar. The telephone plug is an RJ11 plug. It's only 4 pins. This is 8 pins. We'll talk about the order in which the colored pairs of cables should get separated or grouped together when you're building your own cables. Now, level 1 and level 2 folks sometimes will be asked to make their own patch cables or crossover cables or rollover cables, although I don't even think rollover cables are a thing anymore. I think most network gear, you can connect to those via USB. But RJ45, okay, I don't remember what the acronym RJ stands for, but it doesn't matter. RJ and the number 45. Oh, let me apologize ahead of time for my awesome penmanship. I'm a lefty, and I use my right hand on the mouse. So this is me trying to draw right-handed as a lefty. Anyway, most likely the cable you see is unshielded twisted pair or UTP. Shielded twisted pair is a little bit thicker. The insulation is a little thicker. The cable is a little less flexible for bends like this. Generally speaking, and we'll come back to this, shielded twisted pair is used in environments where EMI, or electromagnetic interference, is a big deal. It is more expensive, it is thicker, and it is a little more difficult to run around bends and places where you have to do things like this. So most admins I know, they just make use of unshielded twisted pair, unless shielded is called for. Right. A network protocol, it's a suite of rules. Okay, you and I are going to have a conversation face to face. Well, okay, we're going to have a conversation. We have to agree. Is it going to be via Teams or Zoom? Is it going to be face to face? Is it going to be via text message or email? Okay, and then we have to agree, right? If I say we are most certainly going to get together on Zoom and you join Teams, we're not able to talk to each other because the choice of rules we're following is different. Okay? Or if I speak English and you speak Spanish, okay, we're going to have a hard time communicating because we don't speak the same language. Okay? So protocols are just that. They're rules that define how communication happens between nodes. This is a logical bus network. This would be the backbone cable. Now, this could also be a representation of a star-based network, but no. Let's stick with what I said initially. This is the backbone cable. This would be some version of coax cable. Thin net or thick net. It's just referring to the thickness, the stiffness of the coax cable. If you have Comcast cable at your house, look at the back of the modem, that black cable that screws in, that's coax cable, specifically thin net. Now, back in the day, what we used to have to do, because this would be one long contiguous cable, we needed a workstation to connect. So we would have to cut the cable here, and we would put on a vampire tap. That's legit what it was called. So it would look like a T, kind of like this. Okay, and the coax cable we cut, this end would go in here, this end would go in here, and this cable here that connected to the PC would go here. Now, there were teeth inside here to stop the cable from sliding out, and then a little screw connector. So you would have to screw the cable here and here and here. And you would have to do that everywhere that a machine was connected. On the end, we would put another connector called the terminator. Long story short, without terminators on the end of bus networks, if this laptop wanted to talk to this laptop, if this laptop wanted to talk to a machine that was not on the network, the packet of data, and we'll talk about packets and data later, would traverse the wire, hit the wire. Hey, I'm looking for a machine that would normally sit here. I can't find it. That packet would hit the end of the network, and without a terminator, it would do this. Then it would go all the way to the end of the network. No terminator. Now, over time, theoretically, that packet would be undeliverable, and then the network would... But imagine a network with 4 or 40 or 400 machines on it. Traffic bouncing all over the place like a Super Bowl. That's what terminators were meant to stop. Okay, bus networks won't function properly without them. Fortunately, you should never have to work on a bus network. They're almost as old as I am. Okay, so sharing. I'll talk a little bit about sharing now. We'll talk much more about it later. Back when I first started in IT, not many people had printers. But then all of a sudden, printers became a thing, and everybody got one. Yeah, great. Different makes, different models. Some would be inkjet, some would be laser, some would be dot matrix. Great. Now we've got to store the paper for the dot matrix printer. And laser printer paper and inkjet printer can be the same depending on what you're printing. Toner cartridges, ribbons for the inkjet printers. You'd have to store all that stuff. With the introduction of networking, what some companies have done. I'm taking away your printer and your printer and your printer and one printer for the work group. Now, I use the term work group here. We'll talk about work groups and domains again as we progress into the semester. But right here and now, suffice it to say, if this network, and I'm talking about the topology of the network, is correct, the protocols used by all of these hosts are correct. The addressing scheme we use is correct. Any one of these four machines can print to this printer. Now, that's not taking into account permissions and ACLs, access control lists. Again, these are things we'll build towards. Okay, that's meant to be a picture of a hard disk drive. More recently replaced with SATA drives, SATA. Some people pronounce it SATA. 6 of one, half a dozen of the other. It doesn't matter to me how you pronounce it. This is a representation of a mechanical hard disk drive, or HDD. This would be a platter that would spin. This is a read-write head with an actuator arm that would spin back and forth. And now, well, geez, this has been a thing for a little while. We'd have a computer that would sit over here, and it would be a little bigger, not physically, but spec-wise. It would have more disk space, more memory, more CPU, etc. Because we're sharing out resources like hard disk storage. Okay, now I'll use the term disk storage, and when I do, I'm talking about hard disk drives, HDDs, solid state drives, SSDs, and something I don't know if the new iteration of this class talks about non-volatile storage. Okay, NVM, and then a lowercase letter e here. Yeah, again, my apologies for the penmanship. Non-volatile memory plugs into a PCI Express bus. Again, something we'll build to. This file server here would have more disk space, more memory, more CPU, because you've got 1, 2, 3, 4, or 40, or 400 hosts connecting to it. Yes, this is more expensive, but now what can I do with this? I can back this one machine up somewhere, okay, in a concept we're going to call disaster recovery. That's meant to be a delta, DR, disaster recovery. Okay, we'll talk about backups and things like that again. This is meant to be an intro, so let's not get too deep in the minutia here. I can connect these machines to one server, make that server a print server. I can turn this machine into a domain controller. If we talk about Active Directory versus work groups, okay, we'll talk about those kinds of things, okay? But right now, I can share printers, I can share disks, I can share processing power, okay? So maybe we'll talk about VDI and RDS, virtual desktop infrastructure and remote desktop services a bit, okay? So I can share that out. Folks can save Word documents, spreadsheets, music. I talked about the spinning hard disks. Now, some of these concepts might seem a bit simplistic if you come from a network background. Okay, I'm not going to apologize for that. The reason that this information is in this deck is the course designers, they can't guarantee that everyone who's registered for this class is an experienced professional. You might be someone just getting started in IT, and you have no idea what a file share is, or maybe you don't know what voice over IP is. I lost my mouse, there it is. You know what VoIP is and things like that. So those of you who have a background in networking, more than the basics, please stick with me. We'll get to the more the meat and potatoes of the class later on here. SneakerNet was a thing back when I was in my 20s and 30s, just getting started. Well, geez, do young folks today even use email? If the answer is no, you better start getting used to that at work. I've been a vendor engineer for Microsoft for 4 years, and I get anywhere between 1 and 300 emails a day. That's no joke. So yeah, it takes some time to keep my mailbox sorted and in order. Teams, Zoom, WebEx all allow for the sending of IMs, right? Not just phones, but I can use those communication applications, social media, right? LinkedIn I use a little bit. Facebook I log into maybe once a day. I'll look at Instagram for, I don't know, 10 minutes a week, give or take. Yeah, okay. The reason that this is on this slide, the internet is one big network. Okay, I say one big network. It's actually lots of networks cobbled together, but social media is in and of itself part of a much larger network infrastructure. Okay, we might talk about ERP, enterprise resource planning software, and CRM, customer relationship management software, as we go. Telephones now can be connected to your IP network. Well, geez, you can't have websites without networks. You can't really have any of this stuff without networks, but okay. Now, I don't know who put this slide together. Okay. Compared to what? I guess would be the question. If I typed something on my computer and I couldn't send it to you via email, but you needed to have it, how would I get it to you? Well, I guess depending on where you lived, I'd drive it to you, mail it to you, send it via UPS, get it on a plane somehow, whatever the case may be. But if you've worked in the IT industry for longer than 10 minutes, yeah, everything we do costs money. Many of the places you work, they look at IT as a cost center, which I think is a huge mistake because everything that companies do today relies on what we provide them in network access. Okay, I don't care, right? Warren Buffett reads the Wall Street Journal every day. Well, he probably gets the paper delivered to him, right? But he probably is also on his stock ticker every day. Well, how's he getting that? He wouldn't get that without the network. Okay. What if you're a bank and you're working with deposits and withdrawals every day? Sure, we can go back to the old style forms if you're old enough to remember when credit cards, you put them in the mechanical machine with a piece of carbon paper and you ran the heavy hammer over the top of it and it made that chunk chunk sound. Sure, we could go back to that. Okay. IT costs money. Okay. I'm sorry, that's the truth of it. But do we, if we are given the proper projects and the proper budget to implement those projects, we will save you money, even though you're spending money today. Okay, a little pain now to save lots of pain later is the way I look at it. Okay, I don't know what she's looking at. I can't. I'm trying to see the reflection. Every time this slide comes up, I kind of look over here and I wonder what she's looking at. I've looked at my laptop in a data center like this a number of times. Not with this thoughtful, what's that Michelangelo statue, The Thinker? Or was that Da Vinci? Not with this kind of look on my face. Normally it's a, oh, you've got to be kidding me kind of look. The look of pain. Why I would be connected locally to a device, especially nowadays, when we talk about software-defined WAN and connecting to things like a Cisco Meraki where you can do it from the cloud. But anyway, I digress. Okay, peer-to-peer networks. You have stuff at home, I'm assuming, whether you use it or your kids use it or your spouse, your partner uses it, whatever. Right at my house, I have a personal computer. That's what I'm sitting in front of right now. I've got my work computer, a laptop that's on the over my left shoulder. My wife and I both have cell phones. We have a TV that's connected to the network, and I have a PlayStation 3 that I have not turned on in I don't it's been a minute, let's put it that way. I'd probably have to clean 2 inches of dust off it. I haven't touched it in so long. But these items in my house, they're set up in what is called a work group. And we'll differentiate work groups from domains later on. But excuse me, a peer-to-peer network. A peer-to-peer network. So I've got all these devices in my house. I've got a Linksys switch that they all plug into, and then over here, I've got my Comcast cable modem. Yes, I'm a Comcast cable customer, and you can complain about their customer support all you want. But my only other choice where I live is Verizon DSL. Yes, I'm not kidding. It's going to be 2023 in less than, what, 2 months? About a little more than 2 months. And those are my choices where I live. Okay, so here is my Comcast cable modem. And then way out here, this is supposed to be a cloud, but I'm not going to try to draw right, because that's what it looks like when I try to get artistic. Okay, the internet is out here. So my phone, my wife's phone, my printer, my PlayStation, my TV, my personal computer, my laptop, all connect to this device. Okay, this is called a switch. And what I want you to remember about a switch now, because this will come in handy later, my switch is a layer 2 device. And we'll talk about the OSI model as we get there. My switch works with physical addresses, media access control addresses, or MAC addresses. MAC addresses are physical. They run at layer 2 of something called the OSI model. My Comcast modem works like a router. We're going to talk much more about routers later, but routers are layer 3 devices, meaning they run at layer 3 of the OSI model. They are concerned with the logical addresses on my network, or IP addresses. Okay, again, more details to come. Okay, peer-to-peer network, yep. I've got one printer. I can connect to it from any device in my house. I've never tried to print from the PlayStation or the TV, but okay, yep. Relatively speaking, my network setup is kind of inexpensive, especially compared to an enterprise level network, but I've only got a few devices on my network, not a few hundred. Okay, yes, at home, a peer-to-peer or workgroup network is perfect. But once I get into an office of more than 10 people, you should be looking at not peer-to-peer, but something called client-server. And we'll talk about client-server in a little bit. I can centralize my storage on a peer-to-peer network. It's about the same difficulty, I would say, setting up a folder on this machine and allowing everybody to connect to it. It's not really that difficult on a workgroup network. It depends on how many devices you have, whether or not it's difficult to support. Okay, but the number I use is 10. Once you hire your 11th employee, you're probably going to want to go to client server. Okay, peer-to-peer, much less secure, and we'll talk about some of the reasons why. Yeah, it can be hard to back up. Well, that really depends. Again, prone to viruses, huh? Well, I don't want to say that my network is impenetrable because that would just be wrong. But I run both software and hardware firewalls. I run antivirus that I pay for and that I update regularly. I run consistent scans against my machines. But that's because I work in IT and I know, to an extent, I know what's out there. And I've seen what happens to unprotected networks or networks that you don't put a lot of thought into. So the prone to viruses thing really boils down to the skill of the person managing your network more than anything else. Okay, so once you get to that size, client server is the way to go. A server is just a computer that has more stuff. It has more horsepower, theoretically. Now, I could buy a server on eBay that's less powerful than the phone in my pocket, right? But if I'm doing this at work, this is not a viable option for me. Okay. This guy says shared web server. Okay. This server can be streaming server. You can download music and movies on your server and make them available to anything else in your house. You can connect a printer to a server, share it. The storage that's in this server can also be shared. Now, I can share these things on a peer-to-peer network as well. It's debatable whether it's easier here or there. Okay. One thing I'll tell you that is easier, if it's done right, is backing up. If I'm using this as my shared file server, so my documents and your spreadsheets and our manager's Excel reports all get saved here. Okay, whether I buy a second server or hook up to the cloud, I only have to back up for disaster recovery purposes. That's supposed to be a D, not a P. Good grief. Okay, DR. I only have to back up, theoretically, one device. Now, I've seen peer-to-peer and client networks where you're backing up multiple devices, but again, let's not get into the weeds here. Sure, I can use Mac and Linux and Windows. I drew that X because that's a second Windows machine. Workstations all together, right? And they'll all play nicely, assuming you know how to set them up properly, because all three machines now, your Linux box, your Mac, and your Windows box, they all talk using the same protocol, IP. So it doesn't matter that the hardware inside these boxes is the same or different. It doesn't matter that the operating systems between these boxes are different than this one. I can configure my network so that this Windows machine can see this Mac machine by its address. This Windows machine can see this Linux machine by its address. And each of these two machines can see that printer, that shared storage. Now, it's a little more difficult than that, right? Because you have to set up other things. But because they all talk the same language, easy peasy. Okay? Client-server networks are super scalable. I'd say they're more difficult to support because they require a level of knowledge that you setting up your phone to connect to your Wi-Fi network at home doesn't need to have. Data protection can be easier, but again, that boils down to the skill of the person you're having run your network. Okay, I'll tell you some stories as the semester goes on, time permitting, of just some of the stupid things I've seen in my 30 years. Yes, client servers are expensive, and planning should be required, but sometimes it's not done that way. Again, I'll share some stories with you as we go. All right, so let's talk about addressing. Now, we're not going to talk at too deep a level yet. And I keep saying that, I know, but listen, this is the introductory piece. So as much as you might be chomping at the bit to, hey, get me into the good stuff, you've got to walk before you can run. Okay. So when we're talking about addressing on a network, generally speaking, I'm talking about two different things. I'm talking about the logical address, which is the IP address. I'm talking about the physical address, which is the MAC address, Media Access Control Internet Protocol. For those of you who are not networking proficient, let's say that we all live on Oak Street in some town, any town, USA. Now, somebody wants to send you a snail mail letter, a postcard, whatever. How does that person address the postcard that you get it? I need to know your house number, your street name, your city, state, and zip code. Think of those things together as your IP address. You and your family could sell this house, and move into this house. Your address will change. IP addresses are, comparatively speaking, they're more dynamic. I don't want to talk about spoofing, not just yet. MAC addresses theoretically are statically assigned. They cannot be changed. Now, again, I don't want to talk about spoofing. We'll get to that. But IP addresses are the equivalent of house number, street name, city, state, zip. Okay? So logical versus physical address. Okay, your computer network is set up the same way. So here we have a couple workstations. We have a multi-station access unit, this thing used to be called, way back in the day. Excuse me, I don't mean to keep clearing my throat into the headset, but my seasonal allergies are out of control. This is called a switch, a network switch. Okay, I'm not going to spell the whole thing out, right? SWITCH, switch. These devices are going to get dynamically assigned logical addresses. Now, we'll talk about static addressing later on, right? IP addresses, generally speaking, are dynamically assigned and they're logical. But they have to be unique. No other device on this network connected to this switch can have this address. If I go back to this, if you lived at 744 Oak Street and then I just decided, nah, I want my address to be 744 too. Now when the post office gets that postcard addressed to you at 744, who does the delivery driver drop it off at? Whose house? This is exactly the conundrum here. If this if this PC gets on the network and it also gets assigned an address of 1, and here you want to send an email to the person sitting at this machine, there are 2 machines with the same address. What do I do? Now, theoretically, this wouldn't be allowed. I've never seen an instance where I could do this long term. Excuse me, it might take a minute for the network to discover a duplicate IP address, but it always discovers it. And one of these 2 hosts will get a message on the screen saying, hey, duplicate IP address detected. And you'll have some issues that you have to troubleshoot. We're going to talk about classes of IP version 4 addresses. This is a class C as in Charlie, IPv4 address. On the previous slide, this workstation was assigned the number 1. This workstation will be uniquely identified with 1. This one might be 2. This one might be 200. We're going to talk about the minimum and maximum allowable possible values here. But how you will start reading IP addresses as they relate to networks. Every machine on this local area network will have the same 3 numbers to start. That is not always true. There are times where that's not right. But for our purposes here, the introduction, every one of these machines, every printer, every server, every phone that you connect will start with 192.168.1. And that's how you read it. Okay? You can say 192 or 192. You will not say 192. If you say 192 in front of a network professional, if you say that at an interview where you're applying for an IT job, well, let's just say you're probably not going to get hired. Okay? I know that's a little nitpick thing. Why is it such a big deal? I don't know why it's a big deal. Okay? It's just been that way for a long time. Okay? 192 or 192. .168.1 dot, and this is where the unique number comes in. This computer is 192.168.1.1. This computer is 192.168.1.200. Yes, I said 200. Okay. If this was 192 here, I would say 192. I would not say 192. Again, I didn't make up the rule. I just know that I've been laughed at, and I have laughed at people that have said these things. Okay? So having the first 3 octets, I don't care if you don't remember that name right now. That'll come up later, and it's going to be the stuff of nightmares for you folks once we get there. Okay? Octets. An IP version 4 address is made up of 1, 2, 3, 4 octets. Okay? The reason they're called octets is because they're made up of 8 binary bits. That's all I'm going to say about that for the moment, okay? So we'll come back to that. Now, do keep in mind, it is possible to have 2 house numbers that are the same, as long as their street names are different. I can have a machine that also ends with .200, as long as this number is something other than 1. Same rules apply here. Okay, now, I'll bring it up because it's here. This is a graphical representation of what I just said. This machine is 1, and so is this one. Hey, I thought you said no duplicate. Yes, I did say no duplicates. But this street name is different than this street name. Okay, so the house numbers are identical. It's the street names that are different. Okay, that's why that's allowed. Okay, a subnet is a sub-network. It is a larger network that is split into smaller pieces. There are a wide variety of reasons you would do such a thing. Okay, and again, we'll come back to that. Local area networks, or LANs, they are L-Tri-C's main campus. L-Tri-C has a campus in Allentown called Donnelly Center, and they have one in Tamaqua called Morgan Center. These 3 rectangles here would be considered a wide area network. Mostly it deals with geography. You might consider L-Tri-C's main campus to be a campus network. You could potentially consider it a wide area network. Now, technically, you wouldn't, because geographically, even though the L-Tri-C campus is it's kind of big. It's not huge, but it's kind of big. Geographically, the buildings are not spread far enough apart to be considered a WAN. So some Weisenheimer might come back and say, well, would that be considered a MAN, a metropolitan area network? And I would say no. That's because a MAN comes up on the next slide here. But memorize the dictionary definition of the term metropolitan area network. So that would be like Lehigh Valley. the hospital, Lehigh Valley Health Network, right? They have multiple offices in the city of Allentown. Well, geographically, they might be 1 mile or 5 miles apart, but they're in the same city. So again, it's a matter of distance. How far apart are these things? Okay. Land's generally the same building, the same campus. Man's generally the same city. WAN's a different city. Okay. Okay. What do I have to tell you anything at all about the internet? I am going to tell you a little bit about this though. Internet service provider. You get your internet from someone. You can't just climb out on a telephone pole with a ladder and hook up some cables and get the internet. Well, I guess you probably could. Don't fall. Don't get caught. Okay. Turning on your own internet is probably something that's physically possible, but I wouldn't recommend it unless you work for Comcast or whatever and you have access to the equipment. Your ISP or Internet Service Provider, you call them up, you pay them a monthly fee, they give you access to the internet. So you can watch Netflix and TikTok and whatever else you do on the internet. Good to go. There's a firewall device here. I'm going to say this. A firewall is a security device. Theoretically, if set up properly, it allows good traffic in and out, and it blocks bad traffic. A lot of that depends on you. You can buy a firewall and plug it in and not configure it at all. You just use the default settings, and you'll be okay. You won't be great, but you'll be all right. You can set some serious restrictions using a firewall, and we'll talk about that more later. The internet's a highway. Hey, I guess that's the analogy they're going for here. Okay, the duplicate slide. Okay, the firewall just blocks some traffic, right? Let's pick on a country we're not getting along with. Let's say Russia, for example. Russia might be trying to send some malicious traffic our way. Now, they're not going to target you specifically, unless you're Jason Bourne or something like that. But they might run scans on entire sections of the internet. And if they find a weakness that they can exploit, they'll try to send you some software like ransomware or a virus, or somebody inside your company might accidentally or intentionally click on an email with a link that isn't supposed to be clicked on, right? You get those emails all the time from Amazon telling you your account's been limited or locked, right? A lot of those are spam, but that's what the firewall does. It looks for bad actors and tries its best to block them. Okay, so the term for this server sits outside the firewall, but it is separated from the internet by your internet provider. The technical term for this is DMZ. Okay, now at the advanced age of 55, I was too young to remember the Vietnam War, but the DMZ, which I believe is where that term originated, it may have been coined before that, but I don't really recall. The DMZ is an area outside of your local network where a machine will have more direct access to the internet. A web server, for example. Right? Amazon might have their database server here and their payroll servers here, right? And the servers that their employees use to clock in and out here. But when you want to shop on Amazon, you're going to go to their website, and their website will sit on a file server that sits outside of the corporate firewall. There are specific rules that say only traffic destined for the web server is answered. So if I'm over here and I try to connect to the web server, yes, I can go there. The DMZ has rules I can set up to allow web traffic. Hey, I'm going to see, can I get to the payroll server over here? The firewall says, nah, you're allowed here, yes, but you're not allowed past me. And so they're going to block my access to that payroll server. Intranet is just internet inside your company. The example I always use is your human resources, assuming you haven't outsourced it to like ADP or somebody like that. Okay? They may have forms that you can get to. An extranet, okay, over a VPN. We'll talk about VPNs later. Okay, we're an hour into this yet, and we're not even halfway through this slide deck. Oh, okay. Physical versus logical. Okay. Let's talk with the ones that aren't in use anymore. Okay. Bus networks and ring networks. Now, I was around for bus networks, and prior to that, I was around for something called token ring, Token, token ring. We talked about bus networks having to cut the cable and putting the vampire tap in there, putting the terminators on there. Ring networks were set up as a physical star, but a logical ring. Now, what that means is, you're going to hear that term quite a bit. Physical something, logical something else. Right? So, logical ring, physical star. Now, what that means is a ring network has this item in the middle. Now, today we call it a switch, but back then it was called a multi-station access unit. Okay, I never called it an MSAU. I always just multi-station access unit. It's a switch. And off this switch, right, this ring network has 1, 2, 3 computers. Here's computer 1, here's computer 2, and here's computer 3. Physically, this is what my network would look like. I'd have this multi-station access unit. I'd have my connection to the router, which led out to the internet. Now, back then, the internet wasn't a thing, really, but so this multi-station access unit kind of acted like the hub in the middle of my network. A physical star. Okay, so right, as I added more workstations, it ends up looking like this, right? Hence the term physical star. Whoops, oh, bugger. Logically, the way that the network communicated over the MSAU was workstation 1 got to talk first. Does workstation 1 have anything to say? And if yes, workstation 1 was able to put its traffic on the network. Might be an email, instant message, whatever. Once workstation 1 was done talking, the MSAU would pass a token to workstation 2. Hey, do you have any network traffic? Oh, you don't. Okay, moving on. Now workstation 3, the MSAU would ask, hey, do you have anything you'd like to say? Yes, I want to reply to the email that number 1 just sent me. The MSAU, the multi-station access unit, would give the token to number 3. Number 3's email would be dropped on the wire. And logically, traffic would traverse the wire this way. Ring networks were tough to support because, oh God, I lost so much blood. The running cables under floors and just, oh God. Yeah, it brings back PTSD kind of nightmares. Running cables in prisons was also kind of challenging. I got cut a lot in... anyway, we'll talk about that stuff maybe later. Okay. Let's not... Okay, great. We're not going to talk about that at all. No, we're going to come back to this. Switches. Bus networks, ring networks I talked about. I use the numbers 1, 2, and 3. The authors here are using the letters A through D. So let's, all right, I might as well talk about this here. Let's talk about physical stars and logical stars. Okay, I'm not talking about a logical bus physical star. I'm talking about Ethernet networks, the ones that we use today. Okay, Ethernet, okay, generally abbreviated ETH. Ethernet networks replace the multi-station access unit with a switch. Okay, I'm not going to spell out the whole word for obvious reasons. Whereas a ring network asked, workstation A, do you have anything to say? Oh, you do. Here's the token, which gives you permission to talk. An Ethernet network connected to a switch. All these workstations can be talking, roughly speaking, at the same time. There are some rules that have to be followed in order for that to happen. But let's say that the internet is over here. There's my rendition of a cloud. And the internet is connected to my router, which is connected to my switch. So let's say that workstations A and C are having a conversation with each other, right? They're both circled in red. I'm trying to load a spreadsheet from this file server. I'm sending an email to this coworker. The switch allows a dedicated circuit or communication pathway. Workstation A is talking to workstation C. In the ring days and bus days, workstation B had to wait its turn. Now let's say that you log into workstation B and you want to go on Facebook. I know you're surprised, but Facebook is out here on the internet. Thank you, Captain Obvious. Back in the day, workstation B had to wait till you were done talking or till me and my coworker were done talking. Now with Ethernet and switches, the switch says, oh, B, you have something to say? Yes, I want to go to Facebook. And it will open a dedicated circuit to the internet. So you can be talking to Facebook at the same time I'm talking to my coworker. Okay? Ethernet packet switching. Okay? We'll talk about that a little bit later. Okay? Ethernet networks are logical stars and physical stars. Okay? More details to come. This is a mesh network. And mesh networks are generally drawn this way, although they are always missing the hardware in the middle. I am not buying a computer with 3 network cards in it and connecting one card to this machine and another card to this machine and a third card to this machine. No, there are switches and routers that go in here. But what I'm trying to do with a mesh, M-E-S-H, topology, excuse me, is set up as redundant a network as I can. The Department of Defense, all right, those of you that were in the military, if one installation gets attacked or taken offline, right, if Washington, D.C. for some reason would be attacked, the military installations could still talk to each other because there are these failover points, okay, a mesh network. I try to increase redundancy as much as I can. Now, maybe we'll talk more about that as we go. Okay, and a wireless topology. Okay, now again, this diagram is missing the physical hardware and the cabling. Yes, a wireless network requires some cables, not from your laptop or your phone to the network access device or the wireless access point, but that wireless access point has to be connected via a cable back to some piece of hardware. Okay, so generally speaking, wireless signals on diagrams are denoted this way. Okay, so physical and network, let's see how much of this I can skip past. Okay, so they want us to have some discussion time, but because this is an online class, what I might do is I might throw this into a discussion on Canvas. Right, I told you in the last video, I don't have access to the course shell yet, so I can't start populating my stuff. So I'll have to write this up separately. But I may ask you some questions like this. Now, normally, I'll write them in my own words, and I'll write them in such a way that if you search for what I'm asking you on Google, you'll get the answer. I'm not a huge fan of like changing up words to try to trick you or anything like that. Okay? And I'm coming up on the hour here, so we'll go a little bit farther, and then we'll stop for the time being. Open systems interconnection model. Now we're going to talk about the 7 layers of the model, and we might start the encapsulation discussion. Okay. So OSI, more recently, it's not been replaced by, but it's not even been enhanced by. The 2 models are running side by side. There is a TCP/IP model as well, which is only 4 layers, but this is 7 layers. Back in the day, I got my start working with Compaq, COMPAQ hardware. Compaq was purchased by Hewlett Packard 20 years ago. Compaq, DEC, Digital Equipment Corporation, DEC, other vendors back then, Sun Microsystems was another one. They were all big about vendor lock-in. Compaq hardware would only work in Compaq servers, and the protocol spoken by Sun Microsystems machine couldn't talk to a DEC system. Mainframe operating systems, there were a half a dozen of them. So generally what happened was if you bought into a vendor, you were stuck with that vendor. So the folks who designed the rules that we as internet engineers, technical engineers have to follow, some pretty smart people, they write up these things called RFCs, requests for comments. And one of the RFCs they wrote was, wouldn't it be nice if we could allow vendors to design what they can design? So if you're an application developer, you just have to write your application, but I don't want you writing code that makes it explicitly run on Compaq but not on Sun. Now, that's a poor explanation, but what they were trying to do, among other things, is standardize, and they wanted to get away from one vendor doing what they wanted to do and other vendors doing things entirely different. So if your job is to design protocols, then that's all you do. You write protocols based on a set of standards that the OSI model defines for you. If my job is to write an email application, I can write that email application without having to worry about what protocols are being used. Okay? And that's where OSI comes into play here. It tried to divide up the development of networking stuff into these 7 layers. All people seem to need data processing. These are the order of the layers from top to bottom, 7 to 1. You are going to be expected to have these 7 layers memorized, and how you're going to remember them. All people seem to need data processing. On the day you schedule the actual cert test, or on the day you take my midterm, my final exam, a quiz or an assessment, where you're being timed, you can make good use of the first 2 minutes of the actual test by writing out things like the OSI model. There are 100 other things I'm going to tell you when we get there. Hey, this is something you're going to want to write out like on your scratch paper ahead of time. Now, when you take the actual certification exam, they don't let you bring anything into the exam room but yourself. But they'll give you the little mini dry erase, not a dry erase board, but it's like a sheet of paper that's been laminated, and they'll give you a dry erase marker. And I always say to people, write down the stuff that when you're in the middle of the test and you're like, oh God, I only have so many minutes left, you're likely to forget in your panic. Write that stuff out first. All people seem to need data processing. Each of these 7 layers is responsible for one set of things, and there might be a little bit of overlap, not really, and each of these layers will encapsulate data in such a way that it is readable and usable by the next layer. So let me see if I can summarize that. I'm going to send you an email. You're the receiver, I'm the sender. I open Outlook, I type your email address, I type a subject, the body line, I hit send. The application layer, now I'm going to simplify this for those of you who have networking backgrounds. The application layer takes my email and breaks it into smaller segments. We'll call them packets for now. A packet is like a suitcase. You can have small, medium, and large suitcases. You can have carry-on suitcases. Ethernet networks have suitcases of a specific size. Now, the size can vary, yes, but for the sake of this argument, let's say that all Ethernet packets are the same size. My OSI model has to look at the email I'm sending you and say, will all of this stuff fit in one suitcase? And if the answer is no, right, as we're going down the stack, my email might be broken into 100 little suitcases. Each little suitcase will be formatted in such a way. Application layer says, hey, this is an email. The presentation layer gets that email and says, aha, it will add its own bit of code, send it to the session layer. The session layer will add its own little bit of code, and so on and so on. We're going to get much deeper into this as we go, right? But once I get here, my big email, which was divided into 100 little packets, when it gets to the physical layer, right, here's one of my suitcases, and it's got these other 6 items connected to it. I'm not going to draw them all out. Okay, this is encapsulation described poorly, right? But in plain English to start. These packets, these suitcases, are converted to electrical bits. You're going to learn how to count in binary here before too long. And those electrical bits are put on the wire. They're sent to my switch, to my router, to my email server, depending on if it's inside or outside, across the internet, to your router, to your email server, to your switch, and finally to your computer. Your computer will receive all these little mini suitcases. Your OSI model has to unpack every one of these little suitcases. Okay, please do not throw sausage pizza away. You will be asked the question to label or name the 7 OSI model layers from top to bottom, layers 7 to 1, or bottom to top, layers 1 to 7. All people seem to need data processing. Please do not throw sausage pizza away. Okay, so when you take the actual test, the certification exam, on my test, you're going to be able to look it up. So on the actual certification exam, first thing you're going to do on your dry erase board is you're going to remember all people, seem to need data processing. And then when you get asked a question related to the layer, that's not supposed to be a $sign. I started to draw the T mistakenly before the S. You'll be able to look at your 7 letters here and be like, aha, that's right. The session layer is what establishes the communications channel between the 2 machines. Okay? Without having to, all people see, you're not going to have to say that to yourself 100 times during the test. Okay, those are graphical representations of what I just said. Those are the 7 layers. And this is a good place to stop. So please shoot me an email with any questions. I will make sure that my email address is available to you easily, whether I add it to the slides here or I'll put it up in Canvas. But thank you for your attention, and I will talk to you all next time.